everybody. Today we are discussing the paper Class Incremental Learning with the Generative Classifier. So in this paper, the author tried to address the catastrophic forgetting by training the generative model at class level. So here we can see rather than directly learning the conditional distribution like P of y given x, the author proposed to learn joint distribution P of x and y, which is factorized like P of x given y times P of y. And according to their claim, their model, their generative classifier obtained better accuracy when they compared their model with other replay-based and uh, replay-based and generative replay based algorithm. So let's dig down into the paper. So the very basic definitions that I would encourage the uh, audience to read to read this for the basic definition, I would encourage the audience to read the paper, like what is task based and task free class incremental learning. So quickly mentioning about the task based class incremental learning. So in task based class incremental learning, so we split the dataset into a distinct tasks. So we kind of we have the knowledge about the task boundaries, whereas in task free class incremental learning, uh, we don't have the knowledge about the task boundaries. So here is a very good example that is given in this paper, is like, for example, now here is the task 1 and here is the task 2. So this is the task based incremental class incremental learning, but the same data set, when we look from the task free class incremental learning perspective, it will look like this. Okay, let's uh, let's look into the mathematical formulation of this paper. So we know from the Bayes rule, like we can write p of y given x equal to p of x given y times p of y divided by p of x. This is the standard Bayes rule. We know this from the Bayes rule. So now we also know we can rewrite uh, p of y given x p of x given y times this, right? So here we can see p of y is the prior here, and it can be calculated by counting the number of the classes of each class, by counting the number of the samples of each class. So this can be determined. The only unknown quantity here is this, right? And we can in this paper the author approximated a p of x given y, this conditional distribution, using the variational autoencoder VAE, right? So I'll discuss VAE in a separate video. It's a very simple, but right now for we can assume we know about the variational autoencoder. So using the variational autoencoder, we can approximate this conditional density, right? So once we have this conditional density, then like uh, the author in this paper, they use the importance sampling. Uh, they use the importance sampling, and they use the importance sampling like this. I'll explain the each term in this expression. Okay, now S is the number of the samples. Uh, in variational autoencoder, remember we have the encoder and the decoder part. So this is the encoder part of the variational autoencoder for class yi, right? And this is the prior probability. Uh, Z is a sample from the latent space. Q of phi yi is the decoder part of the variational autoencoder for class yi. This is the encoder part of the variational autoencoder for class yi again. So in this way, for each, now xi is a test sample, yi is the label. So for example, we learn the whole data set, and we know in the data set we have we have 0 to 9 classes. So yi is coming from y, which is this, right? And xi is the sample. Okay, so in this way, using the importance sample, we calculate the likelihood. Uh, we calculate the likelihood. So for the likelihood, we can rewrite it like this: arg max p of x given y times this, right? Okay, so in the paper, the author assume a uniform prior on all y, so we can ignore it and we can rewrite the expression like this, right? Okay, so now at the test time, so for example, our dataset consists of uh, 10 classes. So for each class, we are training the variational autoencoder to approximate. We are using the variational autoencoder to approximate this conditional distribution for that class. For example, yi here. So it means for each class we have the encoder and we have the decoder part of the variational autoencoder. So which means we can, for each class, using this using the important sampling, we can calculate the likelihood of a test sample belonging to a particular class, right? So using the importance sample, after this step we will have like 10 likelihood vector, right? We will have the 10 likelihood vector, and using this expression we can calculate the target class. We can say the incoming test sample, for example, let's assume. So for example, I have something like this. This is 0th position, this is 1th, this is 8th, and this is 9th, right? So using argmax, we can see at the first position we have the maximum value. So we can classify the test sample is belonging to class 1. Test sample belonging to class 1. So this is the whole paper. So quickly summarizing the methodology of this paper. So the author actually reformulate the whole problem in a very intelligent way. Like instead of training the discriminative classifier, instead of learning this distribution P of y given x, they try to learn the P of x given y, which is kind of like a generative distribution, and they convert, they reformulate, they try to use the generative classifier to to classify the incoming sample. So in their paper they are also mentioning about the like how they reformulate the class incremental learning in our in a task incremental learning. So here we can see this given y. This is actually means if uh, this means like we are given some information about the label. In task incremental learning, remember, in task incremental learning we always need information about the task. We always need id, task id. So here we can see, you can see like they actually intelligently reformulate the whole problem and make it easy for their algorithm, and they obtained like promising results. Let's quickly look into the comparison table. Here is the kind of like variational autoencoder formulation. As I said before, I will explain variational autoencoder in a separate video. So here we can see the comparison. It's kind of like hyperparameter setting for their model, and here is the comparison. They compare their model with generative replay, with model with methods that fall under the generative replay, and with methods that fall under the regularization category, and with methods that fall under the bias correction, and their according to their experiment their model obtained performed well. Thank you so much for watching this video, and This was my very first video, and I hope in future I will be able to improve the video quality and content, and I'll be able to organize them well. Thank you.